Welcome back to Low to High Level. Last time we created our basic logic gates, which allowed us to build our building blocks for the system. Today we're going to get to our first bit of computing. We're going to take a couple logic gates that we built on last time, and we're going to create what is called a half adder. This is a system that allows us to take one bit and go and add them two together. So 1 plus 1 is 2. That is the simplest way we can do it, and everything that we will do in the future will depend on this half adder. So, let's get to it. Before we get started, I'm going to discuss the idea of a truth table. So a truth table is a basic table, and we have certain ideas. So, for example, we have A. So we are going to create different ideas. For example, when we discussed A XOR, for example, we had a P, Q, and an R. So we had P, a Q, and we also had a P XOR Q. These are the basic ideas. So with these values, we can build things. So for example, let's assume our Q is true, and our P is true. Otherwise, it'll also be true or false. This will be false or true. This will be false or false. Which is very basics of a truth table. You fill out your inputs and their possible values, and you have your output. So in an XOR gate, as we mentioned, if both are true, we are false. If true or false, we are true. In this case, we are true. In this case, we are false. That was how we designed an XOR gate. For what we're going to be making is a half adder, which means we're doing basic math of a single bit. So let's assume that we have a P and we are adding a Q. So similar to this other instance, we have true or true, true or false, false or true, or false or false. In a half adder, we have two different outputs. We have a sum, we have a carry. And I'll shorten this to S and C. Our sum, so if we are adding 1 and 1, will be 0, and our carry will be 1. If we are adding just 1, our value is 1, or 1. If we are adding 1, value is 1. If we're adding nothing, it's just 0 or 0. In all of these cases, false is the same as 0. True is the same as 1. They're essentially the same concept. So we have to figure out, how are we going to create these gates? Looking at these two gates, there's something familiar here. False, true, true, false. Well, we just did this up here. This is P XOR Q. And what we had over here looks quite familiar. This is P and Q. So we now have our two inputs and our two outputs. Let's go into the logic simulator. Hey, quick editing note here. I noticed that in my system here, I was showing P and Q, and I mentioned that. That is correct, but the logic I gave in the truth table was P or Q. That's just a little note to make sure that everything is correct. When we actually go and implement this, we will be using AND. All right, we're in the logic simulator, and we have our two inputs. As I called them earlier, we had our P, and we had our Q. And of our two outputs, we had a sum, and we had a carry. when we looked at our two inputs and outputs, we had an XOR and we had an AND. Our AND determined our carry, and our XOR determined our sum. For this to work, we just have to go into our two values. This is going to get ugly very fast. Okay, so we have 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 1 is 2. So, if we save this, we have a half adder. Awesome! Today we created a functional half adder. This will be so amazing in the future for what we're going to do. If you like this video, please don't forget to subscribe. If not, there's a couple more videos on one of these sides, who knows, that you can watch. Thank you. Bye.